Hi everyone, I'm Madhumita Pillai, a final year biomedical engineering student from TKM Institute of Technology, Kollam. I am a member of Group 5 of Biomed 360, and now let's analyze the significance of ECG machine through a very eminent professional, Mr. Leio A V, who is currently doing his Masters in Engineering research work in Medical Devices and Technologies under Auckland Bioengineering Institute at University of Auckland, New Zealand. With that, I request all of you to give your full attention to his expert opinion.
Good afternoon, everyone. I warmly welcome each and every one of you to this very interesting session. So, first of all, I would like to invite for today's session, Mr. Leio A V, and also other participants as well. This session is based on ECG device coordinated by the fifth group of Biomed 360 campaign. Let's take a quick glance into what Biomed 360 aims at. The ultimate goal of Biomed 360 is to get a virtual learning experience to comprehend the functioning of medical devices. This campaign focuses on bringing together all the students from the biomedical sector. This campaign is a joint initiative by IEEE EMBS young professionals, IEEE student volunteers, and biomedical engineering students with the main aim of building the biomedical society. Here, the biomedical students and graduates collaborate with biomedical professionals from various sectors and work on gathering data and information on various medical equipments. Thus, reaching out to common people could be an eye opener to the biomedical society in building every student's knowledge regarding the versatile range of devices. Today we have with us Mr. Leio A V, mentor of Group 5, who is currently pursuing Master of Engineering Studies in Medical Devices and Technologies at the University of Auckland, Auckland Bioengineering Institute, New Zealand. He has done MTech in Biomedical Engineering from VIT University. He has also worked as a research engineer at Narayana Nethralaya Eye Hospital, Bangalore, India for 2 years. Not only this, but he has also contributed to the teaching field by working as an assistant professor at KMCT College of Engineering, Calicut for 1.5 years, and also another half year as assistant professor at TKM Institute of Technology, Kollam. We are so lucky and honored to have such an eminent and experienced mentor to guide us all along the campaign. A warm welcome to you, sir.
Thank you.
Now let's move on to our session. The first question that I would like to ask you, sir, is that we all would like to know more about yourself and how you have flourished in biomedical field.
Yes. So actually, I have actually my previous qualification was like BTech in Electronics and Communication Engineering. That was my graduation, and after that, I thought of I had like an interest in medical area. So I prefer to choose my masters in the field of biomedical engineering, and I have done my biomedical engineering masters in VIT. And all along, through my experience in VIT, actually, I have gone through an internship during my second year of masters, and at that point of time, I chose my career, a proper career as biomedical engineer. So, while doing my internship at Narayana Nethralaya Eye Hospital, Bangalore, I got an experience to work with an eminent uh, and a good scientist, all along as a chief scientist in the area of imaging and biomechanics of an eye. So I was working with him for 2 years in a project which was funded by Bioptigen. It's a company in US, and actually they funded the project. And it was a good experience working with them because it is the only one and only company in the world who is providing a micro integrated, I mean, an integrated microscope for the cataract surgery. So I was doing a project, which I was doing a part of the project. It was not a complete project, and I could make a good result out of it. So that was my first opportunity as a biomedical engineer, but not into a medical devices, but I was mainly into the medical imaging sector. And later on, I got an opportunity, and I was waiting for an opportunity. But meantime, I was working as an assistant professor in various colleges. And later, right now, I got an opportunity last year in this University of Auckland, as and that was very like factor for me, because it created a very good impact in my profile. As a biomedical engineer, everyone will look on to how to flourish in the field of biomedical engineering and what are the areas through which we can grow. So I was just searching for that. So at last I found an opportunity here in Auckland University, or it is also known as Auckland University. So here in the mechanical department, it is not in a biomedical engineering department, but mechanical engineering department. There is a course or a coursework to the PhD. It is medical devices and technology. So right now I am associating with Fisher and Paykel Healthcare. It's a company. It's a MNC which is which is originated in New Zealand itself, and it has a lots of different branches and outlets all over the world. And here in New Zealand, they have the production unit as well. So right now, I am working with Fisher and Paykel, as well as Auckland Bioengineering Institute, where I am doing a research on uterine imaging, where I am doing a project. It is like how a fetus is adapting from mother. So that is a project which we are focusing on. So these all are done with images. So later on, I can just explain it throughout your questions. So this is how I flourished in the area of biomedical engineering, and it's going on. Yeah.
It's so
Thank you.
good to see. It's so good to hear how you have progressed in this career, sir.
Yeah.
Next, we all would like to know a little more about ECG and how it could change our lives for the better in future.
Yeah. So today's topic, as it's ECG, like everyone knows like what ECG is. So, and I don't want to go to in basics, but again, I am telling that ECG is the thing which records the electrical signals, generally electrical signals from your heart, for checking a different heart conditions. Uh, so the heart conditions can vary throughout different persons. Like it can vary with different persons. So actually, the ECG as such is a very important in a very important like uh, what a diagnostic technique in which a as heart as such is like like a heart as such is going to having if heart is having some problem in internally as well as some external jerks, the ECG can show it up. So the ECG machines right now have different wide perspective. That is, the ECG machine as such is not an entity, because right now it can be visible in a mobile. It can go through a different box systems, and this ECG as such or ECG machine is coming as a digital platform as such. So we need to think of what an ECG and what will be the output of an ECG. So as like as not an expert, but as a good in ECG or working with an ECG, because right now I am working with fetal ECGs. So so difference between an ECG, that's normal ECG from an adult, and a fetal ECG is like a different perspective. That is, a fetal ECG, it's very difficult to achieve, because we all know that, because there are because the fetal motions can occur. So that fetal motions can, because we all know that if there is any motion artifacts occurring, then it is very difficult to occur ECG. So in the case of fetal ECG, it is very difficult. But again, we need to go for that because our research was meant to that. So an ECG coming into the ECG, like how it can occur in the future. That is the ECG. For example, I will speak on more on the fetal ECGs. That is, you all know that. Can anyone tell what is the reading or what is the normal range of ECG for a fetus? Can anyone share that?
Sir, I think nobody knows the answer to this because we haven't thought of fetal ECG so far. So it's
Okay.
a really
Okay. Yeah, it is actually it is coming above 120 beats per minute (BPM). So
okay, sir.
yeah, so compared to an adult ECG, it's very different. So because and that is why we are measuring a fetal ECG with proper care, so that we can get that fetal ECG at the right instant. That is the right a particular time. If we point out a particular time, we need to get that so that we can identify possible like diseases at the stage of fetal at the fetal stage itself. So right now in my project, what I can share with you is the fetal ECG is taken at the time of uh, MRI scanning. So in India, I haven't heard a pregnant lady or pregnant women taken into a MRI room and taking MRI scanning. So, but here I could find that there's in the month of during after the trimester, right, that is from the third month to the seventh month, a pregnant lady can be taken into an MRI room for an MRI scanning. So, why we are doing this is I have already told I am into a project where mom how the fetus is adapted in a mom's womb. So how that adaptation occurs through images. So we are taking MRI scanning at those periods. At the simultaneously, we are occurring the fetal ECG as well. So there is. So I am right now. Right now, I am focusing on that. So and why we are taking fetal ECG is uh, at the point in like at each and every hour interval or at each and every Q peak or we need to measure the we need to take the MRI scan. So each beat, because we already know, I have already told it is 120 above, so it will be so fast compared to an adult ECG. So that cycle, going along that cycle, we need to take the each and every MRI scan so that that image we can identify that image, the diastole and systole happening. So you all know that what is systole and what is diastole. So that systole, diastole and systole and again a diastole will occur in a single scan. So so that is the purpose. So in the future, the ECG is gonna have a very good impact on a biomedical field in various sectors. That is a biomedical field with regarding to the cardiology department, but again with all other different like project ideas. That's all for that. And
Thank you, sir.
yeah,
Next, we would like to know the possible innovations that can be done in ECG device.
yeah. So the possible innovations, the one such innovation is I've already told, that is an innovation of integrating the ECG with MRI or a MRI scan is a very good area of research that is going to happen for the next 5 years, because already it has been started in the year of 2015 where this same technique has been used for different researchers, but they couldn't get the correct result. But right now they are building upon, and I can just tell a different side of it, that is a different trend of ECG gonna happen. That is, first, it is already in the market right now. That is, in the year 2015, while I was graduating, I was post graduating in VIT. One of the ex student from VIT had developed that technology, and it's already there in like in the market right now, which is known as ECG, mobile ECG monitoring. So we already, like in my past, like when I was doing my seminars, I had already done this topic, but later in future, that is just 3 years before or 4 years before, this product came into existence. That is a mobile ECG monitoring device. That is an ECG which can monitor through a mobile, and we can just measure it through a mobile. So it was developed by different companies, and one of the company is Cardiac Labs. So Cardiac Labs is a company, an Indian company, and whose CEO is my ex VIT like a senior. So that is it's a different version, and nowadays, which I have told before, that is a small box systems which that can connect to a USB, and which can convert it to a tablet or a standard PC kind of stuff, and where we can find the ECG data or the resting ECG as well. So these are the different techniques or the different innovations that can happen, but the innovations doesn't withstand with the ECG machine. It is gone. It's having its own different connectivities. That is ECG. What I told first one, ECG with MRI, that scanning, like how it can integrate. So the integration is happening right now. And moreover, to know more on the ECG machine as such, now the research is happening while integrating to different systems. So the integration can happen with different, because we all know that this heart, because heart, brain, like all organs have its own relation between them within a relation. So that relation is utilized by each and every researchers. So right now in my case, I am utilizing an ECG with an MRI, and that MRI I can like it is, and the situation is different. ECG, MRI in the case of pregnant women. So how the fetus is evolving, or with like how the fetus is adapting from mother. So that is a very good innovation right now happening, but it's very like we four group all over the world is working on the same thing. One is in Canada, well, no, two groups in Canada, and one here in New Zealand, and one in Australia. So we are all collaborating each other for the work, and hopefully we get some work in the recent years. Yeah.
Thank you, sir, and we wish you all the very best for your new
Thank you.
venture.
Thank you. Yeah.
Next, yes, sir. Next, we would like to know the relevance of ECG machine.
Okay. That is an interesting thing. That is relevance is like an importance, right? So how the ECG is considered nowadays? That is, we all know that ECG, because in the previous years, or even today, what we are experiencing ECG is, if we have some heart, maybe it's chest pain, or when we have some sudden pressure changes, we'll go to the doctor and we will ask him for like there's a chest pain, or maybe he will suggest on an ECG. So the ECG, like there is in 5 years or before, or 10 years or before, the ECG, the frequency of getting ECG done is was very less. But nowadays the ECG is a pattern. ECG is a life day-to-day life pattern, because each and every time we can monitor our ECG. So that is, for example, there is one technique called exercise ECG. Exercise ECG, or ETT. ETT means exercise tolerance test. So it's a short form of ETT. So word it is also known as a stress test, and earlier it was known as it has another name, treadmill test, because it's almost similar pattern. That is, treadmill, what we are doing, we are exercising. So at the same time we are monitoring the ECG and our variations, the different variations that can happen in the ECG. So so the diseased person can't go for treadmill test, because disease in the sense like acute disease. If it is in a growing stage, we can go for that. But so this exercise ECG is, or ETT is a it's a frequent way of taking ECG. And there is one more test which is very common, that is cardiac Holter monitoring test. Holter, that is cardiac Holter, HOLTER monitoring test, where it records uh, uh, the heart activity in various periods. That is, while sleeping, while we having food, while we are when we are talking, or when we have some like acute stress, or when we are having some kind of like emotion, like mood swings. So at each and every time we can go for testing the same thing. So why we are testing in these points is like, because each and every emotions or feelings are having a different heart variations, through which we can go for a different studies as such. So that's why I have already told you before, that is ECG right now having it's not a single entity, because it's having a different versions or a different integrations that can happen. So these are the two main wings of ECG, and its like what the relevance and its importance, or its importance in the field of biomedical engineering. So as engineers, what we are thinking is how to what we need to think is how to integrate an ECG machine with an idea. So so as an ECG as a topic, we need to think, you guys need to think a lot on a different aspects, how we can integrate an ECG to the worldwide, maybe the heart, I mean the different scenarios that can happen with our health. And I must tell that is there are different ECG platforms, that means different ECG systems that are provided by different companies, but the end result will be same. So but they do have their own different protocols. So what I'm suggesting is, you need to think of 5 different companies, uh, so that how these 5 different companies provide their ECG, their specifications. So go to their technical data sheet and see how the ECG is capable of integrating with other systems. You just go through that, so that it will be easy for you to take into a better projects or any other good ideas later on in the future.
Definitely, sir.
Yeah.
Lastly, we would like to know the benefits of opting the research field in biomedical domain.
Okay. Um, at the same time, I need to introduce. It's not an introduction. It's already in the market. That is G Healthcare, a company. You all know that they have a product called Muse, which is a popular ECG management system. That is, it can be managed. It can be ECG can be managed throughout the web, and it is so you can later on check in Google. That is, it is managed within US, So this is a very good platform for the ECG management, uh, uh, which can happen throughout the various domains in biomedical engineering. So you can visualize that, and uh, and uh, and the final question was like how we can progress throughout, right, Madhumita?
Yes, the
Yeah,
benefits of opting the research field. If there are people who are interested in doing the research
yeah.
field.
Yeah, sure. So I can suggest each and every one of you who are present over here that is that while opting for a research, please consider like a wider area. No, please don't consider a wider area. Please consider a narrow area in which you can point out some differences with some other things. So, for example, what I have suggested is like if we are gonna like see an idea, that is in my case, I will tell you in that scenario so that it will be easy for you to understand. That is uh, in my case, as a biomedical engineer, what I have done before, that is I have done imaging and image processing, pre-processing, everything I've done on ophthalmology, field of ophthalmology. But right now what I'm doing an imaging in uterus. So the entire thing is different, but the focus is same. That is, I am focusing more on imaging or image processing. So at the same time, I have an opportunity to go for medical devices and technologies on the other side. That is, I have opted a device, and I was like working on that with a similar background. So as a biomedical engineer, what I would suggest is go and like you can if you have an idea, go and search in Google like whether there any similar papers regarding that, first of all. Secondly, take that paper, if it is there, take that paper and go a deep into the paper. What is the content in that, what are the results they got, and how it is being translated, that is how it is translated to the clinical aspect. So so that is a different side of. In my case, what I will tell you is when I choose this area of image processing or imaging in uterus, this is already, in my case, this is already done before, well before I was like I had arrived here in Auckland, because the imaging, all imaging, first set of imaging was done. So I had a very different view about this project, because I thought it is a different and I couldn't do anything in the coming years. But right now what I am facing is like it's very interesting. So the second point to my to this question is, each and every student must have a single idea, and don't deviate from that idea. Build some ideas on that, keep on build up some ideas. Later on you will get a position, or you will be in a saturation mode where you can tell like, okay, I'm so confident in rendering that project, because I have a clear picture of that process, and I am focusing on that. So try to what I will suggest is, try to focus on a single topic, and if there are different branches, cut down the branches, take only a single branch, and progress based on that. And in the recent years, biomedical engineering is flourishing, like it's like gonna building up its own branches. So don't worry, biomedical engineering is having a very good role in the future, and not only in these countries, because each and every country is having its own opportunities. So right now in US, Canada, Germany, Singapore, Australia, New Zealand are having production units for this, and even in Mexico, Fisher and Paykel Healthcare. They have a production in Mexico as well. So and they have each production units have its own research and like R&D services. So don't like give hope. Try to put your thoughts and ideas and convert that into uh, a technique which can be used in the future. Okay.
Thank you, sir. So that's the end of today's session. I would like to humbly thank Leo, sir, for taking the effort and sparing his valuable time with us. It
Yeah.
has been
Thank
a
you.
great interactive session. Thank you so much, sir, for enlightening us on the scope and research aspects of ECG device. Thank you once again.
Yeah. Thank you so much. And if you have any questions or queries, you can contact me through via mail because I'll be there online always. But this was a very good opportunity for me to talk to all. So I don't know, like I have seen like I think almost all the students are from TKMT, or
Yes,
is there?
sir.
Okay.
Yeah, few of them are from our college itself.
Oh, okay, nice. Okay, anyway, like all the best to all of you. Try to
Thank you, sir.
yeah, advance in the area of biomedical engineering and give a very good result. Yeah, thank
Thank
you.
you, sir. I would also
Thank
like to thank
Yeah,
my group leader and other members for their cooperation. So, this is Madhumita here, and it's
yeah,
time to adjourn the session. Thank you
yeah.
all for your patience and urge. We'll meet again with more such activities. So, thank you,
Yeah.
everyone.
Okay, thank you. Yeah, bye.
Bye, sir.